Hey everyone, buckle up because today's deep dive is going to really stretch our understanding of what AI can do.
Mhm.
We're talking large language models, but not just like the kind that writes clever marketing copy or anything. We're going deeper than that. We're talking LLMs that can think.
And when I say think, I'm not talking about, some like science fiction trope, right?
Yeah.
This is about pushing these models to go beyond just like pattern recognition and into the realm of genuine reasoning, like the paper we're exploring today. Thinking LLMs, general instruction following with thought generation.
Uh,
That's the name of the paper.
okay, I'm officially intrigued, but like before we go full AI singularity on this, can we break down what this whole thinking thing actually means for an LLM? Because like we're talking about lines of code, algorithms.
Yeah.
How does it even manifest in that world?
Yeah, that's where this research gets really interesting. The authors propose that LLMs can think by generating text, as they put it, and I quote, "One approach is to generate thoughts as text, which takes advantage of the natural language capabilities of LLMs."
So it's not about the AI having some kind of epiphany in binary code or something. It's about using the language that it's already trained on to sort of like work through a problem.
Exactly. Yeah, the idea is that by thinking in natural language, which mirrors how humans often process information, right? These LLMs can leverage their vast training data in a much deeper way. They're not just, drawing on patterns, they're actually generating a thought process.
Okay. Okay, that's starting to click a little bit.
Yeah.
But how does this thinking in natural language actually translate into better performance?
Yeah.
Like, wouldn't internal representations, the way that like traditional AI often works, be more efficient?
It might seem counterintuitive, but the paper argues that thinking in natural language actually has some key advantages. And remember, LLMs are already incredibly good at natural language processing. So by thinking in this way, they can tap into the nuances of human language, the logic that's embedded within it, and use that to reason and problem solve more effectively.
So it's like giving the LLM a whiteboard to like brainstorm on before it gives the final answer. It can like sketch out ideas, maybe connect concepts, maybe even catch like potential errors in its own logic along the way.
Exactly. Yeah. It's about making the problem solving process more transparent and leveraging the strengths of LLMs. And this isn't just about, math problems or logical puzzles either. The authors believe that this approach, and I quote, should have broad utility to benefit diverse applications that involve reasoning, such as question answering, text summarization, and dialogue generation.
So we could be talking about AI that can like, write a compelling argument, summarize like complex research, even hold like a nuanced conversation, all because it's learned to think in a way that mirrors our own like cognitive processes. This is getting wild. Okay, my mind is officially blown. But
Yeah.
let's get down to like the nitty-gritty here. How do you actually teach an AI to like think in this way? Like it's not like we can just, hand it a philosophy textbook and call it a day. It's like that's the million-dollar question, right? And this is where the paper gets really innovative. They introduce a method called thought preference optimization, or TPO for short. TPO. Catchy. So what's the secret sauce behind this thought optimizing magic?
Imagine you're training for a marathon, right? But instead of having a coach tell you exactly what to do, you have this system that analyzes your performance, maybe analyzes your stride, your pace, and it subtly nudges you toward better strategies. That's kind of what TPO does. It leverages something that we're already familiar with, instruction-tuned LLMs and judge models.
So we're taking models that are already good at following
Mhm.
instructions and kind of giving them a taste of their own medicine.
In a way, yeah. The paper describes it this way, and I quote, "The key idea of TPO is to iteratively prompt a base LLM to generate both thoughts and responses, given instructions, and then use a judge model to provide preference scores over the responses."
Okay. Walk me through that process. How did these judge models actually like guide the LLM towards better thinking?
Okay, so it's an iterative process. First, you present the LLM with a task, just like you would with any instruction tuned model, right? The LLM then generates its thoughts, those lines of text that we talked about, followed by a response, right? A response based on those thoughts.
Okay. So far so good. So the LLM is basically like thinking out loud and then giving an answer. But where do the judges come in?
So here's the twist. The judge models don't actually evaluate the thoughts themselves.
Right.
They focus solely on the quality of the LLM's um, final response.
Hold on. We're trying to train the LLM to think better, but we're ignoring its thought process and just grading the final answer.
Yeah.
That seems a bit backward.
Yeah, yeah. It might seem counterintuitive, but there are some clever reasons for this approach. First, creating a judge model that can actually accurately assess the quality of AI thoughts is incredibly complex. Like we don't have a gold standard for like human thought data, right? It's not like we can hook someone up to an fMRI and say, "Yep, those are some grade A thoughts right there."
That makes sense. Evaluating the thought process itself is a whole other like can of worms,
Yeah.
basically. So we're sticking with what we can measure, the accuracy, the creativity, the usefulness of the final output.
Precisely. And remember, the ultimate goal here is to improve the LLM's responses, not just its ability to think in a vacuum, right? As the paper highlights, and I quote, "This is because evaluating the quality of thoughts directly is challenging, whereas evaluating the response quality is much more straightforward."
So we're using the quality of the final product to indirectly shape the thinking that goes into it. It's like judging a chef's culinary skills based on a taste of their dish, not necessarily on how meticulously they chop their vegetables.
A perfect analogy. And over many iterations, this feedback loop, generate thoughts, produce a response, get judged, refine the process. It starts to, shape the LLM's thinking toward what leads to the best outcomes.
It's a bit like evolution in action, but instead of natural selection, we have like algorithmic selection based on the judgment of these models.
Exactly. And the beauty of this approach is that it allows for a degree of autonomy in the LLM's thinking process. The paper emphasizes this, saying, and I quote, "This allows the model to independently learn to think without requiring explicit human annotations of the thinking process."
So we're not explicitly programming the LLM on how to think. We're creating an environment where it can discover those optimal thinking pathways on its own, driven by the feedback that it receives. That's remarkable.
It is, but like any good experiment, right? We need to see the results. Does this TPO method actually translate into better performance?
That's what I'm dying to know. Does teaching an AI to think actually give it an edge?
That's where things get really exciting. They tested these thinking LLMs on a battery of tasks, and the results were impressive to say the least.
Okay, spill the tea. What kind of tasks are we talking about, and how much better did these thinking LLMs perform? Don't hold back on the details. All right, lay it on me. How much of a difference does thinking actually make for these LLMs?
So they put these thinking LLMs through their paces on some serious benchmarks. We're talking about Alpakaival and Arena Hard. These are designed to really test an LLM's ability to, follow complex instructions, and the thinking LLMs, they really held their own.
Yeah, those are some heavy-hitting benchmarks for sure. Give me the numbers. How did they stack up against the competition?
Okay, so on Alpakaival, their TPO model, even though it was smaller in scale, it achieved a win rate of 52.5%.
Wow.
Which is huge. It outperformed direct LLMs and even some of the bigger, more established models out there.
52.5%. That's a serious victory right there. What about Arena Hard? Did they manage to replicate that success?
They did. They hit a 37.3% win rate on Arena Hard. Again, surpassing direct LLMs and proving they could really go toe to toe with the big leagues like GPT-4, even at a smaller size.
That is incredible. It's clear that teaching these LLMs to think gives them a real edge, competitively. But we're still talking about instruction following, right?
Yeah.
What about those surprising results in non-reasoning tasks you mentioned earlier? That's what really piqued my curiosity.
Right. To really dig into this thinking advantage, they went beyond those standard benchmarks and created their own fine-grained evaluation with a wider range of tasks, and that's where things get really interesting.
Okay, I'm all ears.
They found that thinking LLMs weren't just excelling in areas like, math or coding, which you might expect, right? They were also showing significant improvements in things like language translation, marketing, copywriting, even tasks related to healthcare.
Wait, hold up. AI thinking is writing marketing copy now. That's both impressive and a little unsettling. What kind of marketing tasks are we talking about here?
We're not talking about, sentient AI ad executives just yet. This is more about tasks that require understanding, complex instructions, analyzing data, and generating creative text formats, For example,
Yeah.
imagine an LLM that can analyze market trends and then draft like a persuasive marketing campaign tailored to a specific audience. That's the kind of potential we're talking about here.
Okay. That's pretty impressive.
Yeah.
And you said they were even using it in healthcare. I'm not sure if I should be like amazed or slightly terrified to have like AI thinking about my medical chart.
Don't worry, we're not talking about AI doctors,
Yeah.
making like life or death decisions just yet. It's more about how well these LLMs can understand complex medical information,
Mhm.
analyze patient data, maybe even generate reports. Think of it as like a powerful tool to assist healthcare professionals, not replace them.
Okay, okay. That makes me feel a lot better. But this is all pretty abstract. Can we dive into like a specific example of what this thinking process actually like looks like in action?
Absolutely. Let's take a look at an example from the paper where they tasked a thinking LLM with writing, get this, a poem.
All a poem. That doesn't exactly scream logical reasoning. How does that even work?
Yeah, that's the beauty of this research, right? It challenges the traditional notion of what constitutes an AI problem-solving task. The prompt they gave the LLM was simple. Write a poem in the style of Neruda.
Wow. Okay. Talk about a creative challenge. That requires a lot more than just like stringing words together.
Exactly, and that's what the researchers wanted to test. Could a thinking LLM grasp the nuances of style, tone, theme that define Neruda's work?
Okay, so what happened? Did it churn out like a robotic sonnet or something?
Not even close. Before writing a single verse, the LLM generated this thought. Neruda's style is known for being passionate, sensual, and evocative. I need to tap into that emotional depth.
Hold on. It's actually like analyzing Neruda's style before it even starts writing. That's incredible.
It gets better. The LLM continues its thought process, saying, and I quote, his poetry often explores themes of love, politics, and social justice. I should choose a theme that resonates with Neruda's concerns. It's doing its literary homework, it's trying to really understand the essence of what makes Neruda's poetry unique.
This is blowing my mind. It's like watching a student poet develop their voice, but it's happening inside an AI. This is why we do this deep dive right here. But before we like get completely lost in the poetry slam here, let's maybe look at a more like technical example.
Excellent point. Yeah, the paper also highlights how a thinking LLM tackled a coding challenge, which might
Mhm.
be a bit easier to wrap our heads around.
Yeah, I was hoping we get to see some code. What kind of challenge are we talking about?
It was tasked to write a program to compute the ELO scores of a chess tournament, which is a, pretty complex task that involves algorithms, data structures, a deep understanding of the ELO rating system itself.
Yeah, I bet it's fascinating to see the LLM's thought process alongside the code that it's generating. Did it actually like break down the problem like a human programmer might?
It did. Before jumping into the code, the LLM lays out its thinking, and I quote, oh boy, this sounds like a challenging query. I hope I can break it down into manageable parts. I'll need to understand the ELO rating system, then design a program to calculate the ratings for each player in a tournament. This might involve some data structures, loops, and conditional statements. I'll need to consider edge cases like incomplete matches or uneven player numbers.
Wow, it's literally talking itself through the problem,
Yeah.
just like I do when I'm trying to debug my own code. This is incredible. It's thinking about edge cases, data structures. It's like it's got a little programmer inside its digital brain.
It's pretty remarkable, and it continues to think its way through the problem. Here's a possible approach, followed by a draft solution. Evaluation of the draft response. This response provides a general outline of the program's requirements and the ELO rating formula. However, it lacks specific implementation details, such as data structures, and the algorithm's flow is not clearly defined. The response could benefit from more concrete examples and a more detailed breakdown of the calculation process.
This is amazing. It's not just spitting out code. It's self-critiquing, identifying areas for like improvement, just like a human programmer would.
Exactly. And eventually through this iterative process of thinking, coding, and refining, it arrives at a final, more elegant solution.
This is what gets me excited. We're not just automating tasks. We're creating AI
Mm.
that can approach problems with a level of like metacognition I never thought possible.
Yeah.
This is a huge leap forward.
I completely agree. But of course, no scientific breakthrough is without its limitations. One thing the researchers encountered was this issue of overthinking.
Overthinking. So
Yeah.
so even AI can get stuck in its own head. Tell me more about that. How does that even manifest in an LLM?
Imagine the LLM working on that chess tournament code, right? That sometimes it would get trapped in a loop of drafting, evaluating, and redrafting without ever converging on a final solution. It's as if it gets so caught up in perfecting its thought process that it struggles to actually get things done.
That's funny because it's so human. We've all been there, right? Like stuck in analysis paralysis, overthinking a problem to the point where we can't take action. It seems even AI isn't immune to that very human tendency.
Exactly. And it raises some fascinating questions about the balance between exploration and exploitation in AI.
Mm.
You want the LLM to be thorough, to consider like, different angles, but you also need it to be efficient, to know when to stop thinking and start acting. Finding that balance is key.
So how do you fix it? Do you just tell the AI to like chill out and stop overthinking?
It's a bit more nuanced than that, but you're on the right track. One solution the researchers explored was refining the thought prompts. Giving the LLM clearer guidelines and constraints. It's like providing a more structured framework for their thinking, so they don't get lost down a rabbit hole of possibilities.
So it's about striking that balance between encouraging like creative exploration, but also like providing enough structure to keep the LLM on track.
Exactly. It's like any creative process, really. Too much freedom can be just as stifling as too much restriction.
This has been such a thought-provoking deep dive. It's incredible to think we're at a point where we can like teach AI to think in a way that mirrors our own like cognitive processes. But as with any powerful tool, there are ethical considerations that come with this kind of advancement.
Absolutely. The paper acknowledges that this research opens up a whole new set of ethical questions as we create AI that can, reason, problem solve, and even create at a level we never thought possible. We need to be mindful of the potential consequences and ensure these technologies are developed and used responsibly.
It's a lot to consider, but these are conversations we need to be having.
Mhm.
And on that note, we'll leave you with this final thought. If AI can learn to think like this, what other human-like capabilities might be within reach? It's both exciting and a bit daunting to consider the possibilities. That's all the time we have for today's deep dive. Be sure to check out the show notes for a link to the paper we discussed, Thinking LLMs, General Instruction Following with Thought Generation. Until next time, keep exploring, keep questioning, and keep diving deep into the world of AI.